an engineering school in the neighborhood of Bremen and Hamburg. And as you can imagine, we cooperate closely with the AIRBUS people there and also in Toulouse. And this is one of the outcomes of the project. The system is called Online Maintenance Assistance. And the goal of the system is to give a remote expert, and actually you are now all the remote experts, a view on a site, on a component, and in this case it's a stiffener panel. The panel actually belongs to Benjamin Eckstein in his group, but they were kind enough to give it to us in Germany. So in Germany currently we have one of my engineers sitting, Alex. We will welcome him in some seconds. I just want to explain how the system works, so we can have a view on the system itself, an overview somehow. And behind there are 5x5 PCTs distributed. That's a sensor network, and they are linked to an SHM diagnostic unit from a well-known company from Sunnyway. And this is one of the SHM systems which is used at AIRBUS to look into stiffener panels like this and also into larger systems. You have seen the prototype 2 and 3 this morning. The system consists of a hardware and a software, and usually the engineers who have a real impression on what goes on the other side need a view on the component, on the structure of the panel here, in this case, but also on the software. So we need somehow to have both channels. We also have an audio channel to talk to the person in front of the system. And then we will transport the screen signals, or optionally, we don't use this currently in this setting. We can also just take your sensor data and bring it to the other side if you have a visualization software which runs remotely. So on the other side is here the system. It's touch-oriented because everybody wants to play with tablets now, so we made it touch-oriented, and the rule is always that my thumb is the minimum size of a button, so no dialogues which pop up and things like this. So what we will do now is we will switch to Germany. That means on the other side is Alex sitting. So Alex, can you hear us?
Yes, of course. Hello, Germany.
Yeah, okay, thank you. And thank you for being so kind to be awake in the middle of the night. Alex will now first show us the front side, and we have an artificial damage here. This artificial damage is the red button, and this is what we use as a sample, what actually Benjamin and Martin Bach and all the people use as a sample to check whether the system runs correctly. We look on the back now, and you just see a little white spot here, if you see at all. You will later, we will have a macro look on this, because we have a second camera with a macro lens. That's very useful in a lot of settings in SHM as well as in NDI. You need to have some look on the wiring, on the sensors, whether everything is aligned correctly and things like this. So what I will do now is I will switch to the software, or actually I do not switch, but I touch on my screen. I will enlarge it a little bit so that you see more. And I will directly start with the application. That's the damage detection. It's not fair that I don't tell you anything about the rest, but this takes 1 minute, and so I now have the chance to explain what happens here. This is the 5x5 PCT sensor network, and the acquisition was done some 30 minutes ago, so we already have results in the time domain. You see the actuation signal here in blue, and you see the responses, the sensor data here in red. This is just one of the responses, and I could switch now through the 120 paths between all the actuators and all the receiving sensors, but that's not the idea here. Inside the time domain, I can also zoom in. I can do FFT, and all the experts in the lab at AIRBUS and at Excellence can tell me a lot, or told me a lot in the past months on how to interpret these signals, but I'm still not the expert. I'm just the operator of the remote system somehow. So I expect the damage detection to be finished soon. Let's see. still doing the images. We will receive then a two-dimensional picture of the, well, damage distribution, and we will then check whether this corresponds to the damage we have seen. So Alex, would you please, in the meantime, just turn the panel back, because then we can remember where the damage was actually located. It takes quite some time today, but yeah, we'll come to an end now. Okay, so yeah, here is the real artificial damage, and here in the software we see that the SHM system did a good job. So in this case there was no support needed, but it's just mainly to show you how this system operates. So I think you understand the SHM approach. That's quite straightforward. Yeah. So what I will do now is I will switch away the remote control, and I would like now, Alex, if you could switch to the macro lens camera, then I can have a closer look to the neighborhood of the damage. So he turns back the panel, and we see now where the damage is. Actually, we see the other side, and we see also the PCTs here. So put it a little larger so that you can have an impression on how it looks like. It's all perfectly wired, and it operates at your place since several months. And so we know it's all okay, but imagine if you have any kind of problem with this SHM system or with other NPI systems. We also have integrated with ultrasound systems and eddy current systems and a lot of other systems, optimized all the compression to really have it run also over this distorted Wi-Fi connection. So imagine this can be really of good help. Yeah, if we can switch now back to Alex and just say goodbye.
Yeah.